In this video, we're going to look at how to use the soil moisture sensor. For more information and to get all of the code for the programs in this video, simply go to jb.works and then at the search prompt, enter the TMT code shown on the screen. The TMT codes are also printed on the sensors themselves, so you can always get the information you want by simply going to the website. Now the soil moisture sensor is this unit here. This end is placed in the soil and is used to measure the amount of moisture in the soil. This part here contains the electronics and you need to keep that dry, so don't let this get wet or put it into the soil. So what does the soil moisture sensor actually do? Soil moisture is the water content of soil. And as we all know, all plants need moisture. And knowing the amount of moisture in the soil is very important because that's where the plant gets most of its moisture. And of course, if you don't have enough, the plant will die. And if you have too much, the plant will die. So what the soil moisture sensor lets the JackBord do is measure approximately the amount of moisture in the soil that the plant is in. And we can then use this to do things like control the watering system. Just looking at the sensor for a wee while, the way the sensor works is this part here acts as a capacitor. And if you don't know what that means, it doesn't really matter. What's important is that the amount of moisture in the soil surrounding the sensor changes its capacitance. And that's how the JackBord is able to measure it. So the electronics in the end here take that capacitance and convert it into a voltage, which is then fed through, eventually ending up at the JackBord on these white pins here. So this guy will put out a voltage and then the JackBord will use that to tell you how much moisture is in the soil. It's important that the electronic part here doesn't get wet because that's not designed to go into the soil. So really you want to put it into the soil up to about this part here. For this guide you're going to need a JackBord, 3 short female to female jumper wires, 1 M4 bolt, 1 M4 nut, spanner of course, the soil moisture sensor, a glass of water, and a tissue with which to dry the sensor and clean up some mess. Right, putting it together. Okay, first thing we do, usual one, is bolt the sensor onto the JackBord. Again, just for convenience. There we go. Now, we have 3 connections to make. The first one is the ground, so we use a green jumper wire for the ground. That goes from the green pins on the sensor onto the ground pin of the JackBord, like that. Then the second one we'll make is the sensor, which goes from the white pin on the sensor, the line to the sensor, and then to pin B1 on the JackBord. And then finally we want to connect up 3 volts, which goes from the yellow pin on the sensor to the 3-volt line on port B. So to summarize, we have a 3-volt line going from the yellow pin round to the 3-volt pin on port B. The green ground pin goes to the ground on the JackBord, and finally the voltage output from the sensor goes into pin B1 of the JackBord. Have a look at these reference images and check that your connections match these. It doesn't matter if the jumper wires are different colors, the main thing is that the connections are correct. Now that we've got the sensor connected, turn on the JackBord. Now that we've got the sensor connected, we can start getting some readings from it. But before we can do that, we need to calibrate it. And the reason for that is that every one of these sensors will be slightly different to its neighbors. So the value that they read for maximum moisture and for dryness. So what we're going to do now is find the value that it will give us when the soil is completely dry and find the value it will give us when the soil is completely wet. Now the thing to remember about the sensor is that the voltage output that we get is higher if the soil is dry. So if it's wet, it goes down. So the first command we're going to use is gvrb1 space 100 space 0. Now normally we would use GVR space B1 space 0 space 100. But because of the fact that the sensor puts out a higher signal for dry soil, we want to invert that, because for our readings, we want to have a higher reading for when the soil is moist. So if I press that, now the sensor's sitting here, obviously not in soil and very dry. So if I go GT, the reading is 75, and you can see that here. So this is going to be our completely dry reading. And I'll just do another one just to make sure that it is actually 75. So go GT, and yes, it's still 75. So our dry reading is 75. Now if I get a glass of water, now this is our wet reading. Basically, you can't get soil much wetter than this. So now if I run the GT command again, and the reading is 92. So our wet reading is 92, and our dry reading is 75. So let's go ahead and use this in a wee program to make a soil moisture meter. Now just to give you an idea as to why we're doing this calibration, as we mentioned earlier, we want the output from our soil moisture program to be 0 when the soil is completely dry and 100 when it's completely soaked. The readings that we got from the sensor, we got a dry reading of 75 and a wet reading of 92. So what our program is going to do is basically calibrate the system such that a value of 75 will become 0 and a value of 92 will become 100. The easiest way to get the program code is to visit jb.works in your browser and type in the TMT code you see on your screen at the search prompt. So we do that over here, and this will take you straight to the program. And when you arrive there, just select all of the code, copy it, and then go to the program page and paste it. But get rid of the old code first, there, and then we save it. So we've loaded the program, so now we can run it by clicking on the rocket. And you'll see that we get readings from our sensor. So right now the moisture readings over here is 0. Okay, so now if I grab the sensor, and the readings go up. And likewise, if I let go, they go down. And then this is the real test. If I put it into the water, and sure enough, it goes to 100. So that represents very wet soil. And we dry the sensor and it should go back to 0 again, and it does. Now just quickly looking at how the program works. The first thing we look at, we've got two variables here, one called dry value and the other one called wet value. So you take the values that we got from the previous section, in our case 75 and 92, and you set these variables to those values just by typing them into the code. This variable down here holds the soil moisture, which is the end result. That's what we want. And so coming to the program start, we clear the screen, then we just display the title, which you can see at the beginning here. There we go, soil moisture program start. And then this line here is displaying our wet and dry values, so 75 and 92. And finally, we use the GVR command to set up the analog input. And then the next thing we do is we come to the program loop, which is where we stay while we're running the program. And here we're using the map I command to scale our data. So the input reading is from B1. It normally goes from the dry value to the wet value, and we want to scale it so that it goes from 0 to 100. And that's what this whole line does. Then we just display them. So we show the count in brackets, which is this guy here. Sorry, that one. And then we show the raw value from port B1, and finally the soil moisture reading. And then we do that all 100 times. For this next program, we're going to use a gauge to display the values of soil moisture. So once again, we just go to jb.works, and then we put in the TMT code of the program, and it will take us straight to that program. So we select all the code, copy it, and then we'll go back to the program page, just get rid of our old code, paste in the new code, and save it. Now that we've got the program loaded, make sure you're on the Show tab and click on the rocket. And what's going to happen is we will see a gauge displaying the values of soil moisture. So I'm putting my hand on the sensor to increase its value, and sure enough it goes up. And if I take it away so it's dry, it goes to 0. And now if I place it in a glass of water, of course it immediately shoots up to 100. So the sensor's working great and the gauge is working great. So if we just quickly look at the code, it's essentially the same as before. Our dry value is 75, wet value is 92. We display the title and the readings, and you can see on the print tab it's still printing out the values. And then down here we've got the GVR to get the readings and to set up the port. What we've added though is the title, which is this bit up here, and we've added the quit button, which is that one there. And then we come to the main program loop, and again it's all the same except here, and this is where we've used the PG command, which stands for put gauge, and that's what's producing this gauge over here. So you can experiment with the code and change various parts of it, the range, etc., and see how you get on. For more information, visit www.jackbord.works.